Okay, so for this lesson, I'm going to start off with standard 8NS1. And it says for rational numbers, I'm just reading from the top, guys. For rational numbers, show that the decimal expansion repeats eventually or terminates. So I'm just going to take some rational numbers, basically these fractions, and show that they're going to repeat or they're going to terminate, which meaning they're going to stop at some point in a place value. And it contains this say convert decimal expansion which repeats. So in other words, we're going to take a repeating decimal. We're going to convert it into a rational number or a fraction. And then that part's a little harder. So we're going to take a little more time to get this done. This part up here is really easy, okay? I'm also going to add one additional thing in, and then show you how to take a terminating decimal and write it as a fraction, because I'm sure some of you have forgotten. All right, but we'll start off, and we're just going to convert these to decimals on these first four examples, and you're going to see that they either eventually repeat or terminate. I'm going to use long division, okay? The regular division algorithm. And everybody should be familiar with this and remember it. Okay, so to convert a fraction to a decimal, I'll use what we call TIBO. TIBO stands for top in and bottom out. And I already have it written down. I see it now. So basically, we're just going to use long division. Take the bottom number, which is your denominator, and put it outside. That's why you have bottom out. Take the top number, which is your numerator, and put it on the inside of this, your division bar, okay? All right, add a decimal and a zero because we're converting to decimal, so you'll need a decimal and a zero. Bring that decimal straight up, and we're just going to start our division process. You can get no groups of 5 out of 3, so you put a 0. And then you go on and you say, well, how many groups of 5 can I get out of 30? Well, if you have 30, you can get 6 groups of 5. Subtract the 30. So basically, this is a terminating decimal because it stopped in the tenths place. 6/10. Now, something like 1/8, you just continue to do the same thing. Top in, bottom out. Add that decimal and the 0. Bring your decimal up. You can get no groups of 8 out of 1, but you can get one group of 8 out of 10. Subtract 10 minus 8 is 2. All right, so I have nothing left to bring down. So, of course, you're just going to add a 0 and bring it down. And just say, how many groups of 8 could I get out of 20? Well, you can get 2 groups of 8 out of 20. Subtract, you get 4. The only time I want you to stop is when you get a repeating number in your quotient, or you get a remainder of 0. All right, how many groups of 8 can I get out of 40? And that would be exactly 5. Now I got a remainder of 0. So this is simply 125 thousandths. It ends in the thousandths place, therefore it is also terminating. It stops in the place value. All right, we take a look at this one. There are 2 ways to do it. You can keep the whole number. The whole number is the large number in front of your fraction. And you will keep it in front of your decimal. Whole numbers always go in front of your decimal. And you can just TIBO 3/4. So the 3/4 part is the part that you TIBO. And you all should already know what 3/4 is as a decimal, but it's all right if you don't. We'll just go through. 4 goes into 3, won't go. No groups of 4 out of 3. Can we get any groups of 4 out of 30? Yes, 7. If you need a multiplication chart, then I guess I can attach one. I can attach one to Google Classroom if you need a multiplication chart, because I know some of you are not good with your multiplication facts. 30 minus 28 is 2. Or you could just Google one multiplication chart, okay? You got a remainder of 2, so let's add another 0. We don't have anything repeating in our quotient. 4 goes into 25 times. The quotient, guys, is when I say quotient, I'm talking about up here. That's a quotient. The answer that you're getting. So behind the decimal here is 75 hundredths, or 7 and a 5. So behind the decimal here, I want to put a 7 and a 5. I don't want to put that 0. Please don't put this 0 right here. That 0 isn't behind the decimal, only the 7 and the 5. So whatever's behind the decimal here goes behind the decimal there. So basically this is 1 and 75 hundredths. You should have already known that, but though, because 3/4 is 75% of something, or you got 3 out of 4 quarters, you got 75 cents. The other way you can do this is to take 1 and 3/4 and convert it to an improper fraction by multiplying your denominator and your whole number. 4 times 1 is 4. If you add the 3, 4 plus 3 is 7, so I end up with 7/4. And you can just T-bow 7/4, top and bottom out. Add a decimal and a 0. How many groups of 4 could you get out of 7? Well, you can only get one whole group of 4, which will leave you with a remainder of 3 left over. Bring down the 0. 4. How many groups of 4 can you get out of 30? That would be 7. It's 28. After you subtract, you're going to bring down another 0. How many groups of 4 could you get out of 20? That would be 5. So again, you're at 1 and 75 hundredths. So you can either keep the whole number and just T-bow the fraction part, or you can convert the whole mixed number to an improper fraction and T-bow that improper fraction. It's totally up to you. All right. -2 and 7/10. Well, if you're familiar with place value, this is really easy because this is the tenths place. This is the hundredths. This is the thousandths. So if I read this as -2 and 7/10, I know it's going to equal to -2 and 7/10. The 7 has to go right in the tenths place, 7/10. Only one place after the decimal. That's pretty simple if you got tenths, hundreds, thousandths as your denominator, okay? As a 10, 100, or 1,000, or 10,000. Multiple of 10, not a multiple of 10, but a power of 10. All right, but if you don't know that, we're going to go back. I'm going to erase this, guys. I wish this kind of acted like the smart board where I could just circle all of what I want to erase and then tap it in the middle, but it doesn't. All right, so I'm going to keep the whole number -2, and I'm only going to T-bow 7/10. I can get no groups of 10 out of 7, but I can get 7 groups of 10 out of 70. So whatever is behind the decimal here goes behind the decimal here. And I'm just going to do it that way. So we still end up with the same thing. All right, let's take a look at E. So all of these up here, let me go ahead and label all of these. All of these up here were terminating. This was terminating. It terminated in the hundreds place. This was also terminating. It terminated in the tenths place. Ran out of room, but it's okay. All right, E, top and bottom out. Let's see what we get. You can get no groups of 9 out of 1, but you can get one group of 9 out of 10 with a remainder of 1. Add a 0 and bring it down. Remember, we don't stop dividing unless we get a remainder of 0 or the quotient. Again, when I say quotient, I mean this up here starts repeating. All right, how many groups of 9 can I get out of 10? 1. And if you notice, it's going to keep repeating what digit? It's going to keep repeating the 1. So instead of me just continuing my long division, I can write a bunch of the repeating digits and put ellipses or ... Or I can write it with bar notation. You're going to write the digit that is repeating once. So only the 1 is repeating, and put a bar over it. That's bar notation, okay? And this one is a repeating decimal because it's repeating a digit. All right, 2/3, top and bottom out. No groups of 3 out of 2, but I can get 6 groups of 3 out of 20. That's 18. When I subtract, I get 2. Add a 0 and bring it down. How many groups of 3 can I get out of 20? Again, that'd be another 6. But if you notice, this thing keeps repeating. It's going to repeat the digit 6, okay? So I'm just going to write a few 6s. Or you can write it in bar notation. The digit that is repeating is a 6. Only write that repeating digit once and use bar notation. All right, so if I look at the next example, it has a whole number here. So the whole number here is 5. So I'm going to keep that 5. I'm going to write my decimal. And I'm going to T-bow 5/12. Top and bottom out. I can get no groups of 12 out of 5, but if I look at 50, I can get 4 of those. 12 times 4 is 48. 50 minus 48 is 2. Add a 0 and bring it down. How many groups of 12 can you get out of 20? Only 1. 20 minus 16 is, excuse me, not 16, 20 minus 12. Let me go back and erase that. 21 minus 12 is 8 because one group of 12 is 12. All right, how many groups of 12 can I get out of 80? Well, 12 times 6 is 72. 12 times 7 is 84. That's too big. So I'm going to make the 12 times 6, which is 72. And I get another 8 when I subtract. Okay? I'm going to have 12 in the 80 again, which is another 6. Well, what's going to happen? So you're going to keep getting an 8 down here, which means you'll keep getting 80 when you get ready to go. How many groups can go into that? The remainder plus the 0 you bring down. Well, the digit that it's going to repeat is the 6. So I'm looking up here. Only the 6 is going to repeat. So I'm going to write this in bar notation and with ellipses. Okay, that's with ellipses. Or with bar notation, you're going to write down all your numbers, and then when you get to the digit that's repeating, you're only going to write one of them and put a bar over it. Do not put a bar over the 4 and the 1. The 4 and 1 are not repeating. Y'all make sure you're taking notes with me, okay? Make sure you're taking notes, and you can pause this video if you need to. But I want you all to pause the video and try H for me, all right? All right, let's see what you got. I'm going to keep this -4 as a whole number. And I'm going to T-bow 3/11. Add a decimal and a 0. 11 won't go into 3. You can't get any groups of 11 out of 3. You can get 2 groups of 11 out of 30. 30 minus 22 is 8. Add a 0 and bring it down. How many groups of 11 can you get out of 80? Well, that would be 7. I get a 3. 80 minus 77 is 3. How many groups of 11 can you get out of 30? I'm back at 2. So guess what? This thing is not going to repeat just the 2. It's going to repeat the 2 and the 7 because 30 minus 22 is another 8. And that would be another 7. So I'm repeating the 2 and the 7. So now you can go this route with the ellipses, or you can go this route. You can write the 2 and the 7, the digits that are repeating, write them once and put the bar over what's repeating, which is the 2 and the 7. And that's that. See, each one of these are repeating. This is repeating the digit 6. This is repeating the digits 2 and 7. This is repeating the digit 6 as well here. Okay, I'm going to move on, guys. And remember, this is a video, so you can always rewind or go back and play it, or, try to look at something that you didn't get. All right, I threw this in here. It's not really part of your standard, but some of you have forgotten it. So instead of fractions to decimals, I'm going to do decimals to fractions. I'm going to do terminating decimals to fractions and repeating decimals to fractions. Repeating decimals to fractions are actually part of your standard. It's this part right here. But I just wanted to show you how to write a terminating decimals to fraction as well. All right, so I have this place value chart. because some of us have forgotten place value. So it says to convert a terminating decimal, where decimal that stops in the tens, that stops in the hundreds, that stops in the thousands, that stops in the 10,000s. You simply write it the way you would read it and then simplify. So how would we read this? Okay. So the 7 is in what place? Well, the 7 is one number after the decimal. So go one number after the decimal, I would have to say tenths. 6, and you always read the decimal as and. 6 and 7 what? Tenths, because the 7 stops in the tenths place, one place after the decimal. So if I read it as 6 and 7 tenths, I write it as 6 and 7 tenths. When you get to the and part, you always write it as a fraction. Okay, so I say 6 is the whole number, and 7 tenths becomes a fractional part. Okay, I'm going to take a look at this one. This ends up in the hundreds place. It's 1, 2 places after the decimal. Go 1, 2 places after the decimal. You have to say hundreds when you ended this decimal when you said it. So it's going to be -2. The decimal is and. -2 and 57 what? 57 hundreds, because it's 1, 2, 1, 2 places after the decimal. So since I read it as -2 and 57 hundreds, write -2 and 57 hundreds, and it's already simplified. You can't simplify 57 over 100 any further. Well, this is 3 places after the decimal. So if you go 1, 2, 3 places after the decimal, you end up in the thousands place. This is 0 and 275 thousandths. Now, you don't have to put the 0 up. The 0 is your whole number. So I'm going to write 275 what? I said thousandths. Now, I can divide both of these by 25. That's automatically comes to mind when I see anything like with a 75 or a 50 or 25 at the end, or 2 zeros at the end, and it's a large number. Because I always think about quarters. Well, how many quarters would it take to make $2.75? So that's what I always ask myself. So it takes 4 quarters to make $1, another 4 to make 2, and 3 more to make the 75 cents. So that's 4, 4, and 3, which is, 11. Okay, so it's 275 divided by 25 is 11. Now I need to think about how many quarters does it take to make $10, okay? So I'm writing here, how many quarters does it take to make $10? I just look at this as money. Instead of 1,000, I just look at it as $10. All right, so $10. It takes 4 quarters to make $1. So how many would it take to make 10? So 4 to make 1. So I would need that 4 10 times to make $10. So it would be 40. So simplified, that's 11 over 40. Now I'm going to move on to the next one. It's negative. So when I'm going to put negative, that 0 there, you don't have to say it as a whole number, but that 5 is 1, 2, 3, 4 places after the decimal. Count 1, 2, 3, 4 places after the decimal would be 10 thousandths. So I'm going to write -75 and 10 thousandths. Over 10,000, I'm sorry. Divide them both by 25. And I said, well, how many quarters does it take to make 75 cents? Well, 3. How many quarters does it take to make instead of $10, let's say $100, okay? So you have that number divided by 25. Let me show you all something. Over here, it took 40 quarters to make $10. If you add an extra 0 here, you add an extra 0 here. So adding is, I went from 1,000 to 10,000. So I'm going to go from 40 to 400. Just an easy way to do it. And I already simplified. Okay, this is the harder part, guys. Oh, my Chromebook is about to die, so hold on. Let me get it plugged up. Because if it cuts off now, I will have to record all this over again. Okay, here we go. All right, so I have a method, and you may have to use this chart for a while. I hope you understand. I'm going to go through plenty of these, and we'll do more of these tomorrow, too, if you need more help. So let's talk about powers of 10. So we're going to make use of powers of 10 when we're trying to convert a repeating decimal to a fraction. Up here, these were easy. These were terminating. These were all terminating decimals. Let me make sure I write that. These were all terminating decimals. And I have it right here. Terminating decimals to fractions. So that was really easy. You just write them the way you read them. Write the way you would read it, okay? When we get to this, it's going to be repeating decimals to a fraction. Okay, it's not right the way you read it. So let's talk about powers of 10. 10 to the first power, I'm right here in this chart. 10 to the first power is just 10. 10 to the second power is 100. Let me show you how I'm getting those. So 10 to the first power just means a 10. 10 to the second means two 10s multiplied together, which is how you get 100. 10 to the third power just means three 10s multiplied together, which is how you get 1,000. 10 to the fourth power means you got four of those multiplied together. And I think you get the idea of what I'm saying, which is how you get 10,000. But a shortcut is to look at this and say, okay, if it's 10 to the first power, it only has one zero. If it's 10 to the second power, it has two zeros. If it's 10 to the third power, it has three zeros after the one. If it's 10 to the fourth power, it will have four zeros after the one, and so forth, okay? Now, before I even get into this chart over here on the right, I'm going to talk about what a power of 10 does to a decimal. If you're multiplying. So if I have 2 and 75 hundredths and I multiply it by 10, it's only going to push this decimal one place to the right. So if you took a calculator and did 2 and 75 hundredths times 10, you're going to get 27 and 5/10. So basically, a power of 10 takes your decimal and pushes it one place. Well, how do you know it's only going to push it one? How many zeros does 10 have? One. So it's going to push this one place to the right. So anything times 10 just pushes it one place, just pushes your decimal one place to the right. That's all it does. Now, if I were to take that number and multiply it by 100, well, how many zeros does 100 have? Well, 100 has two zeros. So this decimal is going to go two places to the right, which will end up back here after the 5. And we don't normally write decimals at the end. We normally drop a decimal if it's at the end. So I'm going to erase that. So that would just give you 275. Now, what if it was 275? 2 and 75 hundredths times 1,000. Well, how many zeros does 1,000 have? It has 3. So this decimal is going to go, I'm going to write this here. 1, 2, 3. But if you notice, there's no number here, so you have to add 1, a 0. So basically, that's going to change it to 2,750. So powers of 10 push your decimal to the right. Now, how do you know how many places it pushes to the right? Well, you count the number of zeros in the power of 10, okay? Or if you have an exponent, suppose I have 5 and, let me just write this, 15 and 3/10 times 10 to the third power. Well, that's a 3, which means this will have 3 zeros. So I'll push my decimal to the right 3 places. You can look at the exponent too. If your power of 10 is it written in power form, look at your exponent. So I will push it to the right 1, 2, 3, and I will have to add in 2 zeros. So that's 15,300, okay? So you can count the number of zeros and push that decimal to the right that amount of spaces, or you can look at your exponent if it's written in power form and push it that number of spaces, whatever your exponent says. Okay, so since we know what multiplying decimals by power of 10 by a power of 10 actually does, let's go up here and look at the steps in the right chart. So step 1 says set the decimal equal to x. Okay, so whatever repeating new decimal you have, you're going to set it equal to x because we're going to be setting up equations, guys. After you set that equation, that decimal equal to x, You're going to use a power of 10. Using a power of 10, move the decimal so that the repeating part is in front of the decimal. So when you want to figure out what's repeating, and make sure you get that in front of the decimal. Whatever's repeating goes in the front of the decimal. That makes one equation. Using a power of 10, move the decimal so that only the repeating part is now behind the decimal. This makes the second equation. I'm going to go through this. We're going to stack them. Matter of fact, they'll already be stacked after we do these two. So we're going to subtract what we have, solve, and simplify. Is. Stack, subtract, solve, simplify. All right, let me go through it. All right, first thing it says, set it equal to what? Step 1 was set it equal to, set the decimal equal to x. So I'm going to set it equal to x. Okay, after you set it equal to x, you need to make up two equations. You're going to make one equation this way and the second equation this way, okay? So how do you make the first equation? It says using the power of 10, move the decimal so that the repeating part is where? In front of the decimal, okay? Okay, so I'm looking at this right now. What's repeating? Okay, you should say, oh, the 3 is repeating. But this says get the repeating part in front. Get whatever's repeating, okay? The 3 is repeating, so I need to get a 3 in front of the decimal. To get a 3 in front of the decimal, I need to multiply by a power of 10. So this is going to be equation 1. I'm going to put EQU1. I'm too lazy to write equation all the way out, okay? All right, so I'm going to multiply by a power of 10. So if I multiply this by a power of 10, what does that do to 0.33333? Well, 10 times that. What did I tell you powers of 10 do? All right, so it's going to push this decimal one place to the right. So that'll be 3 point, a bunch of 3's repeating, okay? So now, do I have the repeating part in the front? I just need to get the repeating part in the front of the decimal. All right, so if I multiply by a power of 10, it gets just a 3. I don't want you putting 33 in front of the decimal. I only need the digit that's repeating in front of the decimal. So that digit is just a 3. So if I multiply this side by 10, I must also multiply that side by 10. You should always remember that when you're solving equations, what you do to one side, you have to do to the other side to keep it balanced. All right, so now, so equation 1 will just be 3 and a bunch of 3's, okay, over here. Over here, you would end up with, and I'm showing you this, 10 times this gives me that. X times 10 is 10x. All I did was multiply both sides by a power of 10. How do you know what power of 10 to multiply both sides by? All you do is look and say, how many places what must I push my decimal? Does my decimal need to move in order to get the repeating digit in front of it? It only needs to move once. Well, what power of 10 only has 1 0 or 10? So you multiply both sides by 10. That's equation 1. For equation 2, I need to get the repeating part behind the decimal. Behind decimal, okay? All right, so now I can erase this, what I've written. Let me erase that power of 10. I don't need that because that power of 10 was for my first equation. So I don't need that. Now I'm on the second equation. Now I'm going to look at this. I need to get the repeating part behind the decimal. Only the repeating part. Okay, look what's behind this decimal. 3, 3, 3, 3. Is anything else back there besides what's repeating? No. So basically, you don't have to multiply by a power of 10. Why? Because your repeating part, only the repeating part is already behind the decimal. So what you do is you keep this for your second equation. You don't change anything about it. You don't need to multiply by a power of 10 to get just the repeating part behind the decimal. It's all 3, 3, 3, 3, and it's all behind the decimal. So this is your second equation. So it goes right here, okay? And I'm going to line up the decimals. I'm going to keep the x. I'm going to put an imaginary 1 in front of it. Okay, now, done that. I want that to go away. So what, after you get equation 1, there's my equation 1. I got equation 2. Then it says stack them. and subtract the sides and then solve. Well, they're already stacked up underneath each other. That's what's the whole purpose of me lining up my decimals. All right, so you got to subtract each one. You got to subtract each side. So I'm going to draw a line. I'm going to subtract this, and I'm going to subtract over here. I'm going to write this a little better. Okay, so I want you to notice something. I'm going to draw a line. I'm going to look over here on the left. What's 3 minus 3? 0. What's 3 minus 3? 0. What's 3 minus 3? 0. What's 3 minus 0? 3. Basically, these are gone. 3 minus 3, 3 minus 3, 3 minus 3. So when you set up two equations and you set it up the way I told you to set it up, the repeating part kind of like zeroes out. So you're just left with 3. Then let's go on this side and subtract. What is 10x's take away 1x? Well, if I start off with 10x's and take away 1x, I end up with 9x's left. You should recognize this as a one-step equation. All right, so to solve an equation, what you want to do is make sure you get this x by itself. Well, how can I get rid of the 9 to get x by itself? Well, 9 is multiplying x. So the opposite, you got to use an inverse operation. What do you want to do to get rid of 9 when it's multiplying x? What's the opposite of multiplying by 9? Some of you remember, the opposite of multiplying by 9 is dividing by 9. These will cancel. So I have 3/9 is equal to x. Now I want to simplify, so I can divide both of these by 3. So 1/3 is the x. Basically, 1/3 is this repeating decimal. Excuse me. So my answer, when it says convert to a fraction, is simply 1/3. It's a simplified fraction. All right, let's take a look at B. You see this number right here? I'm going to completely ignore that number. Okay? So I'm going to go back to this. That was a whole number. You see how we had whole numbers here, and I just wrote 6. Had a whole number here, I put -2. Same thing here. When I had a whole number here, I just put, why would I be, no, I don't want to sign up. All right, had a whole number here. Had a whole number here, I just put the 5. Had a whole number here, I just put the -4. Okay, so I have a whole number here. I don't have a 0. Let me go back. There's no 0 there. So what I'm going to do is just put the 2. So I'll put it up here. And remember, we're changing these to fractions. So this is going to be my whole number. So since I'm changing them to fractions, I'm going to have some fractional part next to it. And I'll figure out what that fractional part is in a minute. So since I put this 2 up there, I'm going to go ahead and change this to a 0 and set it equal to x. Basically, I'm ignoring that. I'm ignoring that 2. I'm ignoring the whole number because I've written it right here, okay? All right, so now what I want to do is get the repeating part in front of the decimal. I need an equation that puts the repeating part in front of the decimal. So I'm going to actually look at B and tell me what's repeating. Everybody should see it's not the 4, it's not the 1, but the 6 is repeating. So I need to get a 6, meaning one of those 6's in front of my decimal. So my decimal is right here. So if I move it right here, is the 6 in front of my decimal? No, just the 4. If I move it right here, is the 6 in front of my decimal? No, just the 4 and a 1. If I move it right here, did I get a 6 in front of my decimal? Yep. So I need to move my decimal right there. Okay. So how many places do I need to move it to get it right there? 1, 2, 3. So if you need to move a decimal 3 places to the right, what power of 10 are you multiplying by? So we're going to go back here. Which one moves it 3 places to the right? See, times 1,000. 1, 2, 3. So what I'm going to do is multiply both sides by 1,000. I'm going to multiply on this side by 1,000. And I'm going to multiply over here by 1,000. Okay, so you're just trying to figure out what power of 10 you multiply both sides by. So this power, if I multiply by power of 10 on this left side, it's going to change it to 4, 1, 6. Push it 3 places. And then your other 6's can kind of stay back here, okay? If I multiply x by 1,000, I get 1,000x. Okay, now that's equation 1. I'm just going to put the number 1. Equation 2, I need to get the repeating part behind the decimal. And somebody's going to say, well, Miss Blue, the repeating part's already behind the decimal. Okay, now go back up here. What's the key word? You want to use the power 10 so that you move the decimal so that only the repeating part is behind the decimal. So if I go back here, yeah, I see my decimal right here, but what's behind there? A 4, a 1, and a bunch of 6s. But I said only the 6s need to be behind the decimal. So that means I need to get rid of the 4 and the 1 so that only the 6s sit behind the decimal. So if I need to get rid of the 4 and the 1, I need to get the 4 and the 1 in front of the decimal instead of behind. So if I move it right here, do I have the 4 and the 1 in front of the decimal? Nope. If I move it right here, do I have the 4 and 1 in front of the decimal? Yep. And what's behind? All 6s. That's what I want. Only the 6s behind the decimal. So what power of 10 would I have to multiply by to get the decimal to go from here to here? Well, how many places would you have to push it? 2. So instead of 1,000, I say, okay, well, which one pushes it 2 places? 100 pushes it 2 places. Okay? You just look at the number of zeros. You want to push it 3 places, use 1,000. You want to push it 2 places, use 100. You want to push it 1 place, use 10. You're just looking at the number of zeros. So I'm going to erase this because we're not using 1,000 anymore. Let me erase this. So now I want to multiply not by 1,000, but now for my second equation, I want to multiply by 100. That's going to push this 2 places over. So that's 41. And line your decimals up when you write equation 2. Make sure these decimals are lined up right in here, okay? 41 and then a whole bunch of 6s. All my 6s are now back there. Now, if I multiply over here by 100 times x is just 100x. Okay, they're already stacked together, so I'm going to subtract here. And I'm going to subtract over here. Okay, let's work on this left side. 6 minus 6 gone. 6 minus 6, 0. 6 minus 6, 0. All right, 6 minus 1, 5. I need to write this in blank. 1 minus 4 can't do it. I'm going to have to regroup here. All right, 11 minus 4 is 7. That's 3. All right, so that's going to be with 375 on the left.
Teachers, please excuse the interruption.
Hold on, guys.
Just a quick announcement. If you plan on to do the payroll deduction for the Sunshine Club, Ms. Amon needs your orange sheets in by tomorrow, please. So if you're going to do the payroll deduction for the Sunshine Club, we need your sheets turned in by tomorrow, please. Thank you.
Okay, now let's go to the right side. 1,000 x's minus 100 x's. Well, if you take 100 x's from 1,000, it leaves you with 900 x's. Now, how do you get rid of multiplication? Instead of multiplying x by 900, I'm going to divide by 900. But what I do on one side, I must also do on the other side. These cancel. With these large numbers that have 75, 25, 50, or 2 zeros at the end, I always divide by 25. How many quarters does it take to make 375? Okay, so 4 make $1, another 4, 2, another 4, 3. So that's 4, 4, 4, that's 12. And then 3 more makes it 75 cents. So that's 15. Boy, guys, if you don't know that, just take your calculators and divide it out. 900 divided by 25. Well, how many quarters does it take to make $9? Okay, if it takes 4 quarters to make $1, it's going to take 9 of those 4 to make $9. So 9 of those 4 is 36. Okay, that looks simplified, but it's not because even this is divisible by 3. Okay, I got to get rid of that because that looks like a plus sign. I don't know why it's doing it. Why are we going 6? Divide each by 3. That's 5 over 12. So I don't want you to put 5 twelfths. It's actually 2 and 5 twelfths. Because remember, we took that 2 and made it a whole number, okay? Let's take a look at C. Set it equal to X. For equation 1, I want the repeating part where? In front of the decimal. But what's repeating? The 4 and the 5 are repeating. So I need to get a 4 and a 5 in front of the decimal. If I move it right here, I get a 4 and a 5 in front of the decimal. So that means I need to move the decimal 2 places. So what are you multiplying by to move it 2 places? Okay, 100 moves it 2 places. So I'm going to multiply by 100 on both sides. Multiply by 100 on this side. And multiply by 100 on this side. So on this side, it's going to be 45.45, blah, blah, blah. Okay, 45, they keep repeating. And I need to write that better.
Miss Smith, can you come to the office, please? Miss Smith, thank you.
Okay, my computer's in slow motion, guys. Sorry. Okay, and then over here it's 100 times x, so that's 100x. Okay, now I need to get the repeating part behind the decimal. So you ask yourself, go back up here, what's repeating? 4, 5. 4 5s behind the decimal. 4 5s behind the decimal. 4 5s behind the decimal. Is anything behind the decimal? No. Is anything else behind the decimal besides the 4 and the 5? No. So I'm not going to use 100. I'm not going to use 10. Because if I use a 10, I'm going to get the 4 in front of the decimal. So I already have what I need. I got the 4 and the 5 behind the decimal. 4 and the 5, 4 and the 5. Nothing else behind the decimal. So I'm going to keep this whole thing, guys. Keep it. And that becomes your equation too. You don't need to change anything. If you don't need to change anything about it, if you don't need to move the decimal, then you keep what you have. And put your x. I'm going to put an understood 1 there, okay? Then I'm going to subtract on both sides. 5 minus 5, 0. 4 minus 4, 0. 5 minus 5, 0. 4 minus 4, 0. Leaving me with 45. If you have 100 x's and you take away 1, you end up with 99 left over. Divide both sides by 99. Okay, I don't know why it's doing it. Okay, but we're going to erase it. Let's undo. I'm even going to get rid of that bar with a 45 because I don't like it. Divide both sides by 99. These will cancel, and I can divide both of them by 9 to simplify. That's 5/11. So this is simply 5/11 as a fraction. All right, I'm going to show you something. If you have like 2 digits repeating, you can just take those 2 digits and put it over 99. One lesson. It's actually 4500s if it wasn't repeating. Like if you didn't have this part, it would be 45 over 100. But if you reduce it by 1, you get 99. Anytime you have 2 digits repeating decimal, you can say, okay, what's repeating? If it wasn't repeating those same digits, this would have ended up just being 4500s. I'm sorry. Say if it were like this. Let me show you what I'm talking about. I'm trying to show you a shortcut. If it was just 4500s, then you just write 4500. But because it keeps on repeating, you reduce this by 1. Reduce this by 1. Your denominator by 1 and just write 45 over 99. That's a shortcut, but I also showed you how to use the equation. All right, let me go back and show you this one. How many digits are repeating in A? Okay, only 1. So now, what if it were just like this? So you would just write 3/10. But because it's repeating, reduce this by 1. So you end up with 3 over 9. or 1/3. That's a shortcut. Now, could you do that on B? No, you can't do that on B because you have a 4 and a 6 that are not repeating. So you would have to do the equation. You can't even do the little shortcut on D because you got an 8 that's not repeating behind the decimal. Okay? Now, if you had something like this, now only the 1, 2, and the 5 are repeating. So I could just look at it as if, what if I just had this? That would be 125, and that's in the thousands place. The 5 isn't, you would need to reduce it by 1. So it would be, actually, you could write the repeating part as 125 over 999. That's just a shortcut, guys. Something like this. Should be 2 decimals there. Okay, that's repeating. But if you only had this, you would write it as 7/10. But because it's repeating, you reduce your denominator by 1, so you get 7/9. Something like this. If you just had this part, instead of the repeating 3 and 7, you would write this as 2 and 37/100ths, because the 7 ends in a hundredths place. But because it's repeating the 3 and the 7, you're going to reduce it by 1, the denominator by 1. So you're going to with 2 and 37 over 99. That's a shortcut to A and B, A and C. But now you cannot use that on B or D, because on B you got a 4 and a 1 that are not repeating. And on D, behind the decimal, you got an 8 that's not repeating, okay? So if you got anything that's not repeating, you got to use it. You got to go the long route. All right, so here, cancel. I don't want to sign out. All right, so here I'm going to set this equal to X. Why are you trying to sign me out? Oh, no, never mind. I see that. Forget it. I'm even going to get that down there. Set this equal to X. But I want to change this. I'm going to write my 7 and some other fraction. I'm going to change this to a 0. I'm not even going to worry about that 7. That 7 is just my whole number. So I'm going to get the repeating part in the front. Okay, what digit is repeating? Okay, the 3 is repeating. So I need to move my decimal right there. So I need to push it 2 places. Well, what do you multiply by to push it 2 places? 100 on both sides. So that's going to be 80. This is equation 1. 83 and then a bunch of 3's, okay? Equals to 100x. And then for the second, I need to get the repeating part behind the decimal. Only the repeating part. So what's keeping me? I'm going to erase this other stuff. You have to ask yourself, what's keeping you from having the repeating part behind the decimal? Why is it doing that? I have no idea. Okay, I have none. 0 idea why it's pushing it. So I need that 8 out of the way. Then I just have all 3's behind the decimal. That means you're multiplying by a 10. So that would give me 8 and then a bunch of 3's. And then 10 times x is 10x. Now I'm just going to subtract them on both sides. Those 3 minus 3, 3 minus 3, all 0. 3 minus 8, you can't do, so that becomes a 7. Look at that. That becomes a 7, and that becomes a 13. It's 5 and 7. 75. If you take 10 x's from 100 x's, you end up with 90 x's. So now I'm going to divide both sides by 90. And I can divide each of these by 5. 5 will go into 75 and 90. How many times will 5 go into 75? 15 times. How many times will 5 go into 90? 18 times. Yeah. But I can now divide each of these by 3. So that's going to end up being 5/6. So I take this 5/6 and put it right here. So it's 7 and 5/6. That's a bad 5. That's your answer. Remember, that was a 7 as a whole number, so you can't forget that, okay? All right, so what you're going to do is you're going to go through your Google Classroom, the section under Wednesday. You're going to work. Let me see if it's Wednesday for you all. No, it's the section under Thursday. And you're going to work your exit pass. And you can work it in Kami. You can just type it in, but it's a lot of typing on Kami for you all to do it this way. So what I suggest is that you get out notebook paper. You work your exit pass on notebook paper. Please put your name and the date on it, please, and what it is. That is your exit pass. You will use your phone, open up your scanner, scan it, upload it to Google Drive, and then go to Google Classroom. You can go to Google Classroom on your phone or on your Chromebook once you get it uploaded to Google Drive, and attach it to the assignment, okay, that I assigned to you as and under your work. When you click on the assignment in Google Classroom, you're going to see a part that says your work, and you can create something to turn it in, and you're going to create it. You're going to upload it from Google Drive because you will have uploaded it with once you scanned it and saved it as a file and uploaded it using your phone. All right, you'll do that. You'll scan it, upload it to Google Drive, and submit it to Google Classroom. And then you're going to work on your homework because you also have homework listed on a Thursday. All this has to be done by 11:59 p.m., okay? All right, get that done. I'll check it, and we'll talk about what you did wrong on the exit pass and the homework on Friday when you come in for your live meet. And that's all. See you all. You have a good day.